Hello and welcome to the demonstration of the Slurm on Google Cloud Platform solution. My name is Wyatt Gorman. I'm the High Performance Computing Solutions Manager at Google Cloud. Google began our partnership with SchedMD back in 2017. We wanted to add capabilities into the Slurm Workload Manager directly to allow it to harness the elasticity and the scale of Google's compute engine. We've implemented 3 different ways to use Slurm. We're going to be focusing on the cloud auto-scaling capability today. That is the ability for Slurm to deploy directly into Google Cloud as a standalone cluster and to auto-scale up and down instances depending on your job requirements. We also partnered with SchedMD to add burst to cloud capabilities into Slurm so that you can configure your on-premise Slurm controller to burst individual VMs and groups of VMs into the cloud automatically based on job requirements. And finally, we have federate to cloud capabilities that allow you to federate multiple Slurm clusters between each other, whether that's on-prem or in the cloud. We're going to be referring to SchedMD's GitHub, which you can see there, and specifically the Slurm GCP repository within that. And you can run all of the same commands and more that I'm running by following our code lab for Slurm on GCP auto-scaling clusters. So let's jump in. We begin the Slurm on GCP demo in the Google Cloud Console. We're going to go ahead and open up a Cloud Shell, which is your persistent shell in the browser. We're going to go ahead and git clone the Slurm on GCP repo from SchedMD's GitHub repository. We're going to go ahead and open up the TensorFlow basic examples folder. And then we're going to go ahead and list the files there. You can see a few files essential for the operation of the Terraform, but we're going to go ahead and copy the basic Terraform variables example file into a new file. We're going to go ahead and open that file to edit it, and we're going to modify a few key variables. So you see here things like cluster name, project, and zone. We're going to go ahead and modify those to our own information and the central zone. We also see other variables. We're going to go ahead and skip ahead due to time. You're welcome to review those in the GitHub on your own. There are descriptions of each variable in the README. You can also see we're editing machine type to C2 family. We're going to increase our max node count to 100, which is the quota that I have, and our zone as well. You can see the rest of these options expanded out here for further reading. We're going to go ahead and initialize our Terraform and go ahead and apply the Terraform variables that we just specified. That go ahead and creates all of the Terraform information that we specified after we confirm and creates all of the infrastructure. That takes about a minute to spin up the networks, firewall rules, and the VMs that we specified. By default, you get a controller, which runs the Slurm controller as well as an NFS server, and a login node. You can have multiple login nodes as well. We're going to go ahead and use gcloud to SSH into our login node here. And you can see the Slurm message of the day there saying that Slurm is installed and running. We can go ahead and run an sinfo command that will tell us what is going on in the cluster, how the cluster is configured. You can see we have one partition there. We're going to go ahead and wget a MPI hello world script and load the MPI modules, the open MPI modules. We're going to compile MPI hello world, and then we're going to run an sbatch script with that MPI hello world with one node at first, 2 processes, and calling this run script. If we call a watch for srun and sq, we can watch our VM be spun up. In Slurm, we can see it's in an allocating state. We refresh our console, we can see it spins up in about a minute. It goes to an allocated state, and we can see the job gets run just about now for just a couple of seconds. So if we back out and view our output file in slurm-our job ID, we can see the 2 processes reported hello world. If we go back to our sbatch script and modify that to run on 40 nodes, So we're running MPI Hello World across 40 nodes and 80 processes on those 2 physical cores in those C2 standard 4 with 4 vCPUs. We can see it takes just about a minute for those 40 nodes to spin up, 39 nodes rather, to spin up. As you can see on the top row there, and you see them filing into the bottom row. And you can see just past a minute, the job will run, go from configuring to running, and then finish. And then we can go back out and check Slurm-3 now to see all of those 80 processes report in from 40 nodes in our MPI Hello World. Slurm also spins down VMs as well as spinning them up based on job requirements and queue depth. So after 5 minutes, which is the default Slurm timeout, we can see that the Slurm nodes get spun down. That timeout is configurable in the TFVARS file. And if we go ahead and run a sinfo command, we can watch those VMs actually being spun down in real time in both sinfo and in the console. So we go ahead and we can see those idle nodes go to idle percentage, which means they're being deprovisioned, and we can go ahead and refresh the console and see those nodes all being spun down currently. That way you're not paying for any idle resources in Slurm, and you can configure that timeout specifically to your needs. And you can see in sinfo the nodes just spun down. If we refresh the console, you can see they're deleted as well. That wraps up our Slurm on GCP demo. Please see our website at cloud.google.com/HPC for more info. Thanks for watching.